Okay, there is absolutely no way anyone can read this message. I wish I could have encrypted this, but here we are. Here we go. Gone with the wind. Yeet! Okay, there is no possible way Bro Tank Max was able to intercept that message. Intercepted? What we got here? Long message. Yo, Max with the shirt! I got some secrets on you, my guy! What's going on, everyone, and welcome to episode number 8 of Everyday Python Projects. Today's project is to learn how we can encrypt all of our messages with our own secret key. So 95% of the code we're going to write today won't change as soon as we write it. The remaining 5%, however, that's where we can get a bit more creative. There are an infinite number of ways to encrypt a message, and while we'll cover a pretty robust method in this video, you'll have all the tools at the end of this video to encrypt all of your own messages in any way you'd like. Let's get into it. We'll start by importing the necessary libraries. Next, let's walk through how I thought about building this encryptor. So imagine you have assigned a number to each letter of the alphabet, numbers 0 through 9, and all printable symbols. For example, you might have 1 for A, 26 for Z, 45 for the percent symbol, etc., etc. It would probably look something like this. You'll have a map of numbers right here, and the characters that are associated with that number. So let's start by creating a dictionary that has all of those letters, numbers, and symbols. So first let's write a comment, get all character letters. We'll call this all char is equal to list string.printable. Then we're going to create num alpha. This is going to be a dictionary, so dict, zip, list, range, length. I know, kind of nested here and there, but trust me, we'll get through it. String.printable, up to but not including the 95th element. And then write all char. So zip returns a set of tuples that are based on the 2 arguments that we passed. In order to then use that zip object, you have to transform it into what you're looking for. In this case, we're looking for a dictionary, which is why we have dict right here. We're only including 95 elements because the remaining portion of string.printable is the following. Tab, new line, carriage return, vertical tab, and form feed, which is a page-breaking ASCII control character. We won't need these for our encryptor, so we can just exclude them from our dictionary. Smash the like button now, or my entire life will become encrypted, and I won't have the key. Please. So just to recap, num alpha looks like this. And we have a number assigned to each of the characters within string.printable. So it's sort of our master dictionary. Okay, next, we need to create a scrambled list of numbers from 0 to 94 so that we can eventually create our encryptor. So let's write a comment. Scramble the entire string.printable list removes all of these characters. So we can write scrambled list is equal to sorted range length string.printable up to but not including the 95th element. Key is equal to lambda x random.random. I think the easiest way to explain this entire mess is by showing an example in the console. So we can clear this. And I wrote some code from earlier, and for it to work, we need to import random. So let's see what test is. So test is a list of tuples where each tuple has a random floating point and an integer. If we were to write the following, sorted test, we can see that all of these floating point numbers have been sorted into an ascending order. However, notice the integers, they're all scrambled now. So this one line of code that we wrote here did all of this except to return to us the list of just the scrambled integers, not these random floating points. This lambda function is a neat way to assign those random floating point values to each of the integers, and if you want to learn more about the lambda functions in action, check out my video at the top of the screen. Now that we have our random numbers, we're going to pull the values from the dictionary numalpha by passing in each of those random numbers. We can use list comprehension for this. So let's write our comment, create the encrypted list that uses the scrambled numbers from scrambled list to create a random encryption. So let's write encrypted list is equal to, with our brackets, num alpha number for number in scrambled list. So this is going to be a scrambled list of all 95 characters from string.printable that we wrote earlier. If we run this, we can see that these were all pulled from numalpha, and unlike its order, over here, we can see that these are all scrambled, which is exactly what we want. If we then zip the values of numalpha with this scrambled list, we'll obtain our encryptor. So we're going to write our comment, create the dictionary that encodes the raw message, and then we're going to write encrypt dict is equal to dict zip list numalpha dot values, comma, encrypted list. So let's run this and check out encrypt dict. And now we can see if we have a 0 in our message, we're going to turn that into a B. A 1, turn that into an X. U, make it an underscore, and so on and so forth. Thus, we have a way of taking in the characters from our raw message and assigning them a new character so that we can begin the encrypting process. Now that we figured out how to encrypt our message, we can easily decode any incoming messages by inverting our key. Be aware that dictionary inversions only work if all of the values and all of the keys are unique. If we have repeated values and they get turned into keys, the repeated values will be dropped, which means we'll be missing crucial information in our decoder and it won't work. In our case, there are no repeating values in our dictionary, so an inversion is good to go. We can create the decoder by inverting our encryptor like so. Create the decryptor, decrypt dict is equal to v colon k for k comma v in encrypt dict dot items. So this is just reversing the key value pairs. Finally, we need to read the message that we're trying to encrypt. So I have a text file in the same folder as a script, and I'm going to read it like so. Raw message is equal to apostrophes dot join, and we're going to put a bracket in here to make this a list, line dot r strip for line in open text to read.txt. So this reads each line of the text document, strips out any leading or trailing whitespace characters, and joins all of it together in one list. One thing to note, if you're copying and pasting text from the internet, the formatting of apostrophes from certain websites or even underscores, for example, can break the encryptor. It's kind of annoying to deal with, but not that hard to fix. You just have to do a search and replace in any sort of text editor. That said, if you're really using this to encrypt messages, you're probably not copying public data from the internet anyway, so it's not going to be too big of a deal. All right, now that we have our raw message, we can encrypt this by passing each character of the raw message into our encrypt dictionary and returning the encrypted character. So encode the message, encrypted message, empty space, dot join, encrypt dict, thing for thing in raw message. So let's execute everything we have here, and you can see what the raw message is. An easy way to gain weight is to simply increase your caloric intake, the daily recommended value, blah, blah, blah. Shameless plug, this is from my blog. Feel free to check it out in the description below. It's maximusalpha.com. So this is our raw message, but if we're going to look at our encrypted message, it obviously looks like a ridiculous mess, but it's supposed to be because we don't want anyone to easily be able to read our message. If we wanted to decode this, we can use almost the exact same code that we just wrote with only a couple changes. So decode messages, and then we can write decrypted message is equal to empty space dot join decrypt dict thing for thing in encrypted message. Now if we were to run this and check out our decrypted message, it certainly looks like our raw message. However, we want to ensure that the raw message and the decrypted message are 100% identical. So in order to do that, we can write the following line of code. Check if the raw message and our decoded message is the same. Message check is equal to raw message double equal sign decrypted message. So raw message equals decrypted message is a boolean, and we're going to assign that to message check. So let's execute this and see if the raw message and our decoded message are the same. All right, we see that message check is true, so we can rest assured that our decoder is working. Finally, we need to keep a copy of our encryptor so that we can continue to use it should we need to encrypt any more messages. Since our encryptor is generated randomly, it changes each time we run our script. This is the ideal way of encrypting messages, but you'll need to keep track of your encryptor each time you run the script. This can be done like so. First, we're going to import pandas. Then we can write pd.dataframe encrypt dict.items. Columns will be equal to original and code. Close out the parentheses. .to CSV, and we're going to call it my encryptor.csv, and we'll set the index equal to none. So this will take the keys and values for encrypt dict, that's what encrypt dict.items is, and create separate columns for them in the data frame. One column is the original, and the other column is what the original character will be transformed into. Then it's saved to the CSV myencryptor.csv, and we set the index to none so that we don't have it showing up in our CSV. It's irrelevant for our purposes. Once we execute this, we now have our key saved so we can use it anytime we'd like. Just in case you're curious, if you wanted a quick speed test as to how fast this encryptor is, I'm going to run this 5,000 times and see how long it takes to encrypt all of it. So let me just copy and paste some code I wrote earlier. So let's just walk through this. We're importing datetime. We're going to keep track of the time right when the code starts by assigning it to the value start. Here are the 5,000 loops, and this is what we're going to encrypt. It's basically just encrypting our raw message 5,000 times. We're going to print out how long it took for it to start. Then we're going to take all of the characters with the exception of the spaces and append it to this variable test. And the reason we're doing it is we want to get an estimate for how many pages we have just encrypted. A rule of thumb is there's about 500 words per page. So we're going to take the length of test, divide it by 500 to get the number of pages, and then multiply it by 5,000 because that's the number of times that we ran this. So if we run this, we can see it took just over 2 seconds to encrypt 94,050 pages of text. 94 freaking thousand pages in just over 2 seconds. There you have it. In no time at all, you just learned how to encrypt your messages. Needless to say, the script is really, really fast. Make sure to like, comment, and subscribe if you found the video to be helpful, and I'll see you in the next one.